Hello, today we're going to talk about hurricanes and tornadoes. So you're going to try to follow along on the worksheet that the sub just passed out, okay, titled Hurricanes and Tornadoes. So, first slide here, reviewing from yesterday the three stages of a thunderstorm. They're the cumulus stage, and I told you the only thing I really need you to think about on the cumulus stage, or to remember it, all right, is that it's all about rising air. So rising air is rising. It's causing the water in the air to condense, making clouds. All right. Then it reaches the mature stage. Okay, in the mature stage, you want to think about rising air as well as falling air. All right, and remember that this friction here of the rising and the falling is what creates a charge in the cloud, negative at the bottom of the cloud here, and that'll cause lightning. All right, and then the dissipating stage is the rain has cooled off the ground here. The cold front has cooled off the ground, so the rising air is cut off, and the dissipating stage, the cloud will begin to shrink. So really, it all has to do with these arrows here. All rising air in stage one, cumulus stage, rising and falling air in the mature stage, and again, if there's enough friction caused between the rising ice particles here and the falling cold air here will charge the cloud and we can get lightning. And then dissipating stage, it's cooled off. No more rising air from the ground, so basically we're just talking about falling air. Lightning, just kind of mentioned it, lightning is caused by the friction between the updraft and the downdraft. If you went back to the last slide, the boundary between the upper red and the falling blue. Creates a separation of charges, so the bottom of this cloud will be negatively charged. That pushes the negative charge particles on the ground deeper underground, leaving a positive charge near the top. We get the step leaders coming down and the positive streamers coming up. When they connect, we get the lightning bolt. All right. Here we go. I just thought a cool picture of some lightning. So again, positive streamer coming down. I'm sorry, step leader coming down, positive streamer coming up. When they connect, whap, we get the lightning. Thunder. We asked this in the third hour yesterday, so review it for everybody. Thunder. Why does this make a noise? Well, lightning is really hot as 30,000 degrees. It heats the air around the lightning bolt very quickly. So that air expands and then contracts as it moves away from the lightning bolt extremely fast. Fast enough where that movement breaks the sound barrier, okay, which is 767 miles an hour. So the fact that this lightning expands and contracts so quickly, that heat, that air moves so quickly it breaks the sound barrier, and you get a sonic boom, which is actually what the sound of thunder is. It's a sonic boom from the air heating and cooling quickly. All right, that was number 3 on your sheet. So wind and downdraft. So we know that this is the top thrill dragster. Anything that comes up must come down. So as rising air reaches that 40,000 feet in the cumulonimbus cloud, it cools, and when it cools quickly because it's really cold up there, and it comes down with a force. Those are called downdrafts, and they can cause just as much damage as a tornado. Okay? Basically what I just described here, 40,000 feet. So we're up here at 40,000, pretending this is 40,000 feet. As it comes down, the air cools quickly, and that creates a downdraft. Okay, wind that falls very quickly to the surface, a strong wind. That is a downdraft, and that is 4 and 5. 40,000 feet for 4, 5. Just talked about what a downdraft is. All right, draw this one. This is on the back of your sheet. There's a draw this number 1 box. I would like you to draw this thunderhead, okay, or a thunderstorm. Not quite a supercell, but close. We have the updraft. All right, this is really about hail. Well, the updraft is strong enough. It's going to keep all these water droplets in the air long enough and high enough to collect a lot and then freeze. Okay, and then once that hail is heavy enough to break the force of that updraft, it'll fall to the ground. So the stronger the updraft, the larger the hail will be. So if you have just little tiny BB-size hails, it was probably a moderate updraft. If you get something the size of a golf ball or bigger, it was probably quite a large updraft. So a lot of heat on the ground here. So we can pause this, get it drawn, and then move on. All right, here's some pictures of tornado. This is the first photograph, or thought to be the first photograph of a tornado. So this is the main tornado. There's other vertices coming around, but this is basically this whole area is one big tornado. Okay, and sometimes until all this dust catches up and gets to the surface, you'll see multiple vortices. They only last for a short period of time. Okay, but this is really one big tornado. We just haven't had the dust get stirred up enough to kind of cover this up. But most large tornadoes have multiple vortices. All right, here's one that looks like a heart. I thought this was cool. I'm not sure if this is a factual picture or not. It looks like it might be Photoshop, but this could be real. So multiple vortices. Here's another one of multiple vortices. This is a lot of tornadoes in one storm. Okay. So some consist of a single vortex. A few, however, have multiple suction points or vortices. They only last about a minute. All right. Tornadoes. So obviously the larger part here is responsible for the damage. Okay. Most reports of several tornadoes were usually just one big tornado where a few of them kind of came out of the main. You can see these come out of the main vortice. So these are big tornadoes. All right. Here's our draw this too. So we'll pause this. I want you to get this picture in here. So here's our anvil. So the direction of the cloud is this way. So this is the cold front moving in. The rising air is being forced up. So we get the mesocyclone, which we'll talk about in a second, gets tilted vertically and causes a suction here. All right, so that's why the tornado's there. All right, and then what basically happens to a thunderhead or a supercell is this rain in this cold area cools off the ground enough where this updraft is cut off, and then the thing will just dissipate pretty quickly. Okay, overshooting top, you'd be pretty far away from the thunderstorm to see all of this detail. Okay. But because when you're right underneath it, all you're seeing is maybe the mesocyclone here, maybe some rain bands off in the distance. So get this drawn for your supercell. Let's move on. All right, tornado development. This is the mesocyclone with the key here. So this is number 7. Okay. 6 actually. What is a mesocyclone and how does it form? Basically, a mesocyclone is a tube of air. Think of this running across the country from, like, say, California over towards Florida, so in that direction. All right. The winds aloft, so very high up there, are moving at a really high pace. The ones towards the ground are moving at a much slower pace. That causes the top of this wind structure to move quicker, so it rolls over. And then when this mesocyclone gets over the warm Great Plains, it causes this middle part of it to bend upwards, and here's our vertical shaft. So that's number 7 as well. The heat from the Great Plains causes this to tilt upward, and that's going to give you that sucking motion of a tornado. Okay, so mesocyclone is a column of air that's spinning, and it rises or it tilts vertically because of the warm ground. So that gets your tornado action right here. Okay. Faster winds, slower winds. 6 and 7. Let's get on to the tornado development. So here's our mesocyclone spinning. We get the tornado here. All right, very similar picture to the last one. Updrafts and downdrafts. So we get rain on this side. This is the downdraft. Rain over here. Okay. All right, moving on. Tornado classification. We mentioned this the other day too. So the Vegeta intensity scale is F0, so not much at all. 40 to 72 miles an hour. We can get straight winds that travel that fast. F1, you can see this is what it looked like. Probably rustling up of some roof shingles, things like that. Not much. F2, 3, 4, and 5 total damage. F5's winds can be up to 318 miles an hour. There is an enhanced Vegeta scale, the EF scale, that takes into account how well buildings are built as well. All right, tornado watch, conditions ideal for a tornado. We haven't seen one. Warning, we're either seeing one or we can see it on the radar. All right, watch. We're looking for one. Warning, there is one, or we think there's one based on data from a radar. All right. Tornado frequencies. Again, I just wanted to show this really quick. This is the map of the United States. Obviously, this is Tornado Alley, especially in this point right here. All right. Just did that on accident. Let me go back. Boom. All right. Did it again. There we go. And then a frequency one around the United States or around the world. Here's the United States. Europe gets a few. India, China, Australia, Southern Africa, and the southern part of South America. All right, cool picture of tornadoes. Kind of like this one with a rainbow. The 1, 2, 3 vortices. That's a cool one. Lightning right next to the tornado. I like that one. These are called water spouts when they happen over the water. Whoops. Did it again. I'm going to run out of time if I don't stop doing that. All right. Here's one over the middle of a town. That's a really big tornado there. That's not causing that to tilt yet. Here's one during a fire. That's kind of neat. Here's one on a golf course. And hurricanes. Let's get through hurricanes as fast as we can. So, hurricanes are low pressure systems. So there is number 11. You can circle the low. Where do they originate in the United States? They originate off the coast of Africa. Okay? And you can see the path they most likely or generally take. They kind of start near the tropics and then go north and then kind of swing back around as the jet stream kind of forces this way. By the time they're in here, they're tropical depressions or disturbances. All right. Just another quick picture of a hurricane. Low pressure system causes all the air around to swirl in the center. Remember, it's kind of like a funnel going down. This is all hot water, 80 degrees or more, and it causes the air to rise, and we get this organization of the clouds. All right. Here is again where they're originating, way over here off the coast of Africa. Warm water, 80 degrees. They kind of pick up steam from the trade winds. This warm water causes this organization, and they basically travel through that section. Now, why don't they peter out just like a tornado? When the rain cools the ground, it basically kills a tornado. The problem here is there's so much warm water that the rain over is not cooling anything down enough to stop the rising air. So these cumulonimbus clouds become enormous. All right, and that's what causes a hurricane. They don't peter out because there's just so much heat trapped in the water here. All right. 4 stages of a hurricane. You can see them here. Tropical disturbance, tropical depression, tropical storm, and then finally a hurricane defined by the eye, and wind speeds greater than 79 miles or 39 miles an hour is a tropical storm. I think 70s is a hurricane, 79 I believe. All right. Hurricanes, when they're in the Atlantic Ocean, typhoons if they originate in the Pacific Ocean, and cyclones if they originate in the Indian Ocean. That would be number 15. Okay. Oh, and then you'll see 14 on your notes page. That's a mistake. I should have deleted that. What is a transfer in a closed system? That's not a question for this one. And then hurricane dangers. What is a storm surge? Basically, here's a storm surge. We have the height. The low pressure kind of causes the air to rise, and the winds push that high, or causes the water to rise. Just like a tornado sucks up, so does a hurricane. The water level gets higher, and the wind pushes it up the land. This causes the most damage and the most deaths. That is your hurricane notes for today. Sorry I had to rush through it, but I only get 15 minutes on this thing. You have one more worksheet to complete today, and I will see you guys tomorrow.